Today we are continuing on with our quadratic unit, and we are going to be talking about a form called vertex form. So just like in our linear equations, we had the slope-intercept form, which is our y equals form, and that's the one where you can see the slope number and the y-intercept on the end. We also had a point slope form where you could see a point that the line goes through, and you could still see the slope in there. And we also had a standard form in linear. So you can rearrange equations into different formats. So when did you know there were other formats besides the one that we normally see all the time? So anyway, we're going to do the warm-up. The big thing in quadratics is knowing all these attributes and being able to look at a picture and find the different attributes and know where they are. That is the biggest concept we want to make sure that you have really well this year. The other stuff, we're just introducing it to you so it won't be totally foreign to you when you see it again in Algebra 2. All right? So here we go. Warm-up is, again, find the key attributes of each function. And we just have one picture here. We're going to find all these different things over here, right? So we're going to go find this stuff. So here's my picture. It's a lovely parabola. It's a smiley parabola. We want to find the vertex. Where's the vertex? It's where it changes direction, right here, that little tippy point right there. When they ask for vertex, we want the ordered pair for the location of that point. So to get to this point, we start at the origin and we go right 1, 2, oops, just 2. So I went right 2 and down 1, 2, 3. So positive 2, negative 3. We always do the x number first. We do the y number second. So positive 2, negative 3. 2, comma, negative 3. And because it's a location, it is an ordered pair, so it must have parentheses around it so people know it's an ordered pair, not just two random numbers sitting there. Axis of symmetry. Without even looking at the picture, you can immediately go, the axis of symmetry is this vertical line that goes down the middle of my parabola. And since it's a vertical line, it must start with x equals. And what is the x number it's equal to? It's equal to that x number right there. The x number in your vertex is the x number that goes with that equation. If you were to look at the equation over here, or the line over here, this is the line of symmetry, or axis of symmetry. I want the equation of that line. Vertical lines always start with x equals. And what is the x number it equals? It equals 2. So whether you look at the picture to get it, or you look at the vertex to get it, that is the equation of the axis of symmetry. Now, is it a min or a max? It's a low point, so it is definitely a minimum. And what is the minimum number? It's the lowest y number being used, which is this number right here, which is negative 1, 2, 3. So this is negative 3. Without even looking at the graph, could you just looked up here and said, oh, it's negative 3 is my max or min? Now, you wouldn't know without looking at the graph if it was a max or min. So this, since it's a low point, it's a min. But we definitely knew what the number was going to be, right? Okay. Now, what else we want to find are the number of zeros. It didn't ask me to find the zeros. It said how many zeros are there. Determine the number of zeros. How many places is it crossing the x-axis? Because zeros are x-intercepts. It's crossing here and there. So how many are there? There are 2 zeros. There are 2 solutions. There are 2 x-intercepts. All right. Over here, we want to know the y-intercept. So go find the y-axis, and where is it crossing? Right there at positive 1. So my y-intercept is 1. Domain. This is all the x numbers in the picture, and this is range or all the y numbers in the picture. So let's go see what my picture looks like. If I'm doing the domain, the x numbers, I come in from the side and touch the edge of the parabola. Does it stop there with a point? No, it has an arrow, so it's going to go right forever and ever and ever and ever. So I'm going to use all the x numbers to the right. When I come in from the left, I want to know what's the x number that it stopped on. If I come down here, I would pick that number out, except it doesn't stop there. They don't have dots there, it's an arrow. So it's going to go left forever and ever and ever, all the way up that way. So I'm going to use all the x's that way. So I want all the x numbers. So that means I can write out in words all real numbers. I'll write it a bunch of ways here, all real numbers. You could have used an infinity symbol with maybe the x's next to it. Maybe they'll have a variety of ways that they write it. It might even be a positive and negative infinity symbol with the x's. Now, if they put anything with a y, then you say, no, it's not that, because this is all about x's. They could use infinity symbols. There's a variety of ways they can write it with infinity symbols. They might also just use the double R. This is the one I like to use. I just do the double R. That's a shortcut for all real numbers. So, a variety of ways, you're just looking for an answer that means I want all the x numbers. All right? Now, range, the y numbers. If I come in from the top, it doesn't stop there with dots. It has arrows. It goes up forever. So I want all these y numbers going up forever and ever. But does it ever go below this down here? No. And what was that number? We said it was negative 3. We can see it here on the graph. It never goes below negative 3. You can see it here in the vertex. You can see it here in the max or min number. So I've got a y, and I've got a -3, because all of my y's are bigger than this number. These are all my y's up here being used. So if my y's are bigger, does that mean I'm eating the y's? Yes, you eat the bigger number, so the y's are being eaten. My y's are bigger. Is it solid down here at the bottom? Yes. So y's are greater than or equal to 3. Oh, that was a -3, wasn't it? Yes, -3. I should make that little negative sign in there. There we go. So y's are all greater than or equal to -3. Because my min was -3, my vertex stopped at -3, so that's the boundary of where my y's start and where they go up from. Okay, so there's all that. So these are all the key things that we want you to know and be able to do really, really well this year and understand these vocab words. That's the key things that are going to be asked on the STAR test. Now, there are other things they're going to ask you, but we're going to show you all the ways that we can do that, especially with the graphing calculator. But this is the heart that we want you to know for sure. Okay, now in the last unit, we were factoring, so we want you to remember how to factor because we're going to be doing a lot of this next week. So that's why we did Unit 6, so we could do the quadratic stuff. So here we go. I have this lovely expression here, and they want me to factor it. So if you remember on my poster, step 1 says look for a GCF first. So is there any number that goes into 1, 3, and 18 evenly besides that 1? 1 is the only thing that goes into 1. So there is no GCF to pull out, and of course there are no x's in all 3 terms, so I can't pull an x out. So no GCF, but I check that. And then if there's no number in front of the x squared except a 1, I can go straight into trying to make it into a binomial times a binomial. Because factors are things that multiply together to give you an answer. This is the answer, and these are the two things being multiplied together. Typically, when the answer is a trinomial with an x squared, an x, and a number, it started off as a binomial times a binomial. So that's what we're hoping. Occasionally, they're not factorable, but most of the time, the ones we're going to give you will be, but there will be some that won't. What two things multiply together to give you x squared? I need an x and an x. And then these two numbers multiply together to give me the last term. So I need a list of possible numbers that will work. So I'm going to list the factors of 18. Start with 1, 1 times 18, go to 2, 2 times 9, then 3, 3 times 6, 4. Will 4 go evenly into 18? Nope. 5, will 5 go evenly into 18? Nope. 6, yes it will, but 6 has already been used. So those are my 3 choices there. So then I have to decide which pair of numbers to use without trying them all, because that's kind of tedious. You can look at the middle term. If I add or subtract these, will it give me a 3? If I add these, it's 19. If I subtract, it's 17. If I add them, it's 11. If I subtract, it's a 7. If I add them, it's 9. But if I subtract them, I get a 3. So that works. Now I've just got to figure out the signs. I want the answer to be positive, so I'm thinking let's make the bigger one positive and the small one negative. And then test it. Put these in the calculator and add them together. -3 plus 6. Does it equal positive 3? If it does, then we're going to keep them. If not, I'm going to change them and just try some different signs. But this does give me a positive 3. Last thing I got to check is if I multiply them together, will I get -18? So do -3 times 6, and you should get -18, and it does. So -3 plus 6. There you go. Now, if you go back and do the double distribution on multiplying these two binomials together and combine the like terms in the middle, this will be the answer you get. There you go. So there's my factors. X minus 3 is a factor, and x plus 6 is a factor. This is another concept we want you to be able to do really well when there's a 1 in front of the x squared, just doing this little thing right here. This is the concept we want you to have this year. Okay, number 4. Again, we're factoring. Step 1 is always to look for a GCF. So there's a 2 in front of this one, so I'm thinking, well, 2 will go evenly into 2, so let's see if 2 will go into all the other numbers. Will 2 go evenly into 24? Yes. Will 2 go evenly into 36? Yes. So let's pull the 2 out. Now, are there x's in all 3 pieces? No, so the only thing I can pull out is a 2, not an x. So here's my 2 that's pulled out, and I'm going to rewrite a binomial that this times something is going to equal this thing up here. So 2 is one of my factors. 2 times what is 2x squared? I just need the x squared, because 2 times x squared is 2x squared. 2 times what is a -24? I need a -12 here. 2 times -12 is -24. I need an x in the answer, so I should have an x there. So when I multiply these two things together, it equals that. And then 2 times what will give me a positive 36? That's a positive 18. And then check it, 2 times 18 should be a positive 36. So when I'm done, I kind of go back and I distribute everything to make sure that when I do that, I get those 3 pieces. So 2 is a factor, and this trinomial is a factor. When I multiply those two things together, it equals that. Now, we're not done because we want to check to see if this might be factorable into 2 binomials, because it's a trinomial with an x squared, an x, and a number. So I'm hoping that this will also be factorable. All right, so I'm going to go pretend like I think it's going to be factorable as always. So x squared, I need an x and an x. These two numbers multiplied together have to equal 18, so let's make a list. 1 times 18, 2 times 9, it's the same list as over here. 3 times 6, 4 won't go, 5 won't go, and 6 is used. So it's one of these three. If I add them or subtract them, it needs to equal 12. If I add these, I get 19. I subtract, I get 17. If I add these, I get 11. If I subtract them, I get 7. If I add these, I get 9. If I subtract, I get 3. Did any of them work? No. So is this factorable? No. So this can't be done. These are the only two factors. 2 is a factor, and this parentheses is a factor. All right? So sometimes this may be factorable, so you always check it to see. If not, you just stopped where you were. I have 2 factors in that one. But not a binomial times a binomial, was it? Okay, number 5. Again, we want to factor this lovely trinomial that we have here. So I'm thinking, okay, step 1 is always find a GCF if there is one. So there is a number in front of the x squared. Okay, so there's several numbers that will go evenly into 9 besides a 1. 3 will go evenly into 9, and 9 will go evenly into 9. So I'm going to try those numbers on all 3 of these. Will 3 go into 12 evenly? Yes. Will 3 go into 4 evenly? No. So 3 is out. 9 goes into 9. Will 9 go into 12 evenly? Nope. And 9 also won't go into 4 evenly. So there is no GCF. But I'm not done because the next step is to try to factor it into binomial times a binomial. But I can't do it with the 9 in front. So this is when I'm going to do my slide and divide. So we're going to multiply by 9, which means at the end I make myself a note to come back and divide by 9. All right? So rewrite it. The 9 is gone. This is x squared minus 12x. And 9 times 4 is a positive 36. This is my new problem. So I want to make this into a binomial times a binomial. I'm still factoring it. I need an x and an x to give me x squared. And then these two numbers multiplied together have to equal 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 won't go, 6 times 6, 7 won't go, 8 won't go, and 9's already been used. So there's my list. I need a pair of numbers that if I add them or subtract them equal 12. 37 and 35, nope. 20 and 16, nope. 15 and 9, nope. 13 and 5, nope. Ooh, if I add them, I get a 12. Perfect. Now, to get a negative 12, I think they both need to be negative. Let's try that. Negative 6 plus negative 6 in the calculator, should tell you negative 12. And then when I multiply them together, I get a positive 36. Is that what I want? Yes. So both things have to happen. You add them, they equal the middle number. You multiply them, they equal the end number. So negative 6 and negative 6. Minus 6, minus 6. Now, you think, okay, I'm done. There's my two binomials, but no, we still have to divide by 9. So take both those numbers and divide them by 9. Reduce these fractions down in your calculator. Remember, you're using that TI Nspire. So this turns out to be x minus 2/3. And this one also is x minus 2/3 because they're the exact same fractions. Now, we don't leave them in this format, though. I'm going to rewrite it up here. You move the 3 in front of the x. So this becomes 3x minus 2. We move the 3 over here, and this is now 3x minus 2. And same thing here, 3x minus 2. And there I'm done. If you multiply these two binomials together, you get this answer over here. Wasn't that fun? Okay, so I wanted to remind you this is what we did in the last unit, and we want to remember that because we're going to do this a lot next year. Or not next year, in this unit, quadratics. That's why we learned it in the previous unit so we could use it. All right, what we're doing today is talking about that other format I told you about, which is the vertex form. So here's the vertex form. It is on your reference sheet down there in that quadratic section. It is in y equals format, so we can still put these in the calculator and just go trace around it. We can see the parabola just as we always see it, right? But when it's in this format, we can't see the ax squared, we can't see the bx, and we can't see the c on the end. But what we can see is the vertex, okay? So that's why they call it vertex form. You have a number here in front, you got x, you got whatever sign this winds up being, and then you have a number here, and this whole parentheses is being squared. And then you have a number being added or subtracted on the end. This number where the H is and this number where the K is are your vertex in that order. H, K, H, K. Those are your two, that's your vertex of the parabola. So, just like in the point slope form, this is a minus sign here. And so if you cover it up, whatever number that is your number. So if this was x minus 3, the formula is minus, and so 3, positive 3 is the H number. Now this one has a positive sign, so whatever its sign is goes with it. But this one is kind of like you take the opposite. If this had been x plus a 2, that's like a double negative, and so it's actually a negative 2. So we'll talk about that as we go through. But that's why this one's a little tricky, because you have to remember to change the sign on this one, but keep the sign like it is on this one when you fill in the vertex. If it gets confusing on doing that, don't worry, because can we just put this equation in the calculator and trace around it? Yes. So if you don't get the vertex form of it, it's okay. We just want to introduce it to you this year. You'll see it again in your Algebra 2 class, okay? We just want to introduce it to you. This is the normal way we write it in standard form, when you have the x squared, the x term, and the number all on one side. So here we go. This thing is in vertex form because you have this parentheses with x minus, and it's being squared. You have a number on the end and some number in front of the parentheses. So first thing we want to do is we're just going to go through and pick out the vertex in both these first two problems. So remember, the thing inside with the x is the first number in the vertex, and this is the second number. And remember, the formula is minus. So see, this is x minus, so my first number is positive 1. I know it says minus 1 in here, but it's the positive 1. And then here is the positive 3, so positive 3. There we go. That is my vertex 1, 3. When we go put this in the calculator and trace around it, we're going to check that we got that right. Now, since we know the vertex, do we know the axis of symmetry? Yes, it starts with x equals, because it's a vertical line, and that's the x number that it goes through, x equals 1. All right, so on this one, this is in vertex form because we have the x plus or minus a number in parentheses being squared, and we have a number being added or subtracted. So this is the first number in the vertex, this is the second number in the vertex, that's your h and k. But this is a plus sign, so this is kind of like thinking this, the formula says minus, that means there's two minus signs here. So this is x minus a negative 2. So this is a minus 2 as the first number and negative 5 as the second number. Okay, so the second number stays as is. It's the first number that's kind of like the opposite thing. All right, so that's my vertex, which means the axis of symmetry is x equals negative 2. Boom. So when we put this in the calculator in a minute and go do our attributes as normal, we're going to check to see if we got these right. But if we're following the little formula up here, the vertex form, that's what they should be. But I make mistakes when I do this all the time, so that's why I don't always rely on this. Just go put it in the calculator and double check it. Star test A, just put it in the calculator and do it with the trace feature. You don't even have to try to do it this way, but it's a shortcut if you happen to remember it. Now, we need to figure out if it's a max or min, so let's just go put it in the calculator and go graph it and see what it looks like. It winds up being a smiley face. All right, so if you put this in the calculator, type it in just like it is, 3 parentheses x subtract 1, close to parentheses, square it, plus 3, hit enter, you should get a lovely problem that looks like this. And when you do that, we already know the max or min is going to be a 3, we just didn't know until we saw the picture if it was a max or min. And since it's doing this, we know it's a minimum, so I'm going to circle minimum. But once you see the picture, then you know it's a minimum. We didn't know that before just looking at this. Solutions, these are my x-intercepts, so we're going to trace around the graph and look to see where it's crossing the x-axis. It's going to say 0 when you get on one of them. So trace around until you find it. Oh, when you looked at the picture, did it actually touch the x-axis? It did not. It was above it, wasn't it? So is there any solutions? There are none. Y-intercept is where it's crossing the y-axis, so trace around until you're on the y-intercept, and it is at positive 6. Okay. My domain. Domain, remember the x numbers. So if you look at your parabola, it doesn't show arrows on the screen, but there are arrows. It goes right forever and it goes left forever. So am I going to use all my x numbers? Yes, so I want all real numbers. You can do the double R, write it out, all real numbers, or use the infinity symbol. All right, so we're going to do the second one over here. So same thing, put it in the calculator, menu 5.1, trace around it. We're going to go find that tracing feature. And this one turns out to be another smiley face when you put it in the calculator. So this part, go ahead and pause the video, go find your pieces down here, and then come back and check and see if you got this right. We've been doing this for a few days now, so see if you got this. Okay, so hopefully you paused the video and now you're coming back. When you did this, since it's a smiley face, this is a minimum. It's a low spot there. So that's my minimum, and it's the same y number up here in the vertex, negative 5. That's the lowest spot. That's the lowest y number being used in that picture. Solutions, where did it cross the x-axis? They were not pretty numbers at all. One was 0.709, and the other one is negative 0.329. 3.29. Now notice I did not put parentheses around these with a comma. It's not a location. It's two separate numbers, two separate points. So make them separate. It's this number and that number. Y-intercept, where's it crossing the y-axis? You're right, it crossed at 7. And the range, this one's going up, so I wanted all the y numbers bigger than whatever this number was, and that number was a -5. So I want all the y's greater than or equal to, I'm eating the y's because they're bigger, -5. So domain and range, those are some more. We want to make sure we know domain and range, vertex, axis of symmetry, max or min, and solutions, x-intercept, zeros, and of course the y-intercept. Now what they want you to do is to rewrite this vertex equation in standard form. Now remember, standard form looks like this. So the goal is to get y by itself, which y already is, but we just want to simplify this side so that we have it with an x squared and x and a number. So basically we just want to get rid of the parentheses and distribute anything we need to and combine like terms. So we're just simplifying this whole right side. Now when we're simplifying, we're doing math, we have to follow PEMDAS. That means we're going to do what's inside parentheses first, then we're going to do any exponents where you have any little exponent up high, and then once you get rid of that stuff, if there's some multiplication or some add subtract to be done, you're going to do all of the multiplication division first, and then you're going to come back and do the adding and subtracting last. All right, so let's go do that. Parentheses first. So here's the original problem. I'm just going to focus on the right hand side. There's a y equals in front of it, so down here at the end it's y equals, and I'm just going to simplify the right side. So parentheses, here's my parentheses, and it's got x minus 1 inside. Can you do x minus 1? They're not like terms, are they? So I cannot do that. So I have to skip that. Now normally you would think, okay, I want to get rid of parentheses, I'm going to distribute first, right? But that's multiplication. Look at our order of operations here. Do I do multiplication before I do exponents? No. And what was outside that parentheses? There's an exponent outside of it. So I have to do this exponent before I do the multiplication. So be careful about that. We're used to distributing, but there's an exponent outside here. Now this is not like our exponent rules where we multiply the outside exponent times the inside one, because on the exponent rules the thing inside here was a monomial, and we do not have a monomial, it's a binomial. So we're going to do this more the long version. So down here where I have some blank space, I'm going to do this. I'm going to do just this little piece right here is the x minus 1 being squared. So that's x minus 1 times x minus 1. I'm just doing this one little piece here. I'm squaring this thing, which means I'm taking this parentheses times itself. That's what square means. If I've got 5 squared, it means 5 times 5. That's what that little 2 means. So I'm taking this parentheses and multiplying times itself twice. So here's x minus 1 times x minus 1. This is a binomial times a binomial, double distribution. X times x is x squared. X times -1 is -1x. -1 times x is another -1x. And -1 times -1 is a +1. So all I did was that double distribution, and there are my 4 pieces. Combine your like terms, which means I now have x squared, and -1 plus -1 is -2x. When you're combining like terms, don't change my somethings. -1 something minus 1 something is -2 somethings. And then, of course, I still have the +1 on the end. So this piece here, that thing right there, is what this thing was right here. What's still in front of it? I still have a 3. Notice I kept those parentheses around it, right? When I did the final answer, I put parentheses back around it because there were parentheses around it over here. So after I squared this, I still have the 3 sitting out front, and I still have the +3 out back. So I just did this one little piece in here, that x minus 1 times x minus 1, and I put it back in its place inside that right-hand side. So it's still times 3 in the front and +3 on the back. So now, what operation do we first, multiplication or we do addition? We still can't do what's inside because they're not like terms. I'm going to do the multiplication first. I'm going to distribute this. 3 times x squared is 3x squared. 3 times -2 is -6x. And 3 times 1 is a +3. So the parentheses are now gone, but I still have the +3 on the end. See why we did all that polynomial stuff? X squared, x, and these are plain numbers, so this is now 3x squared minus 6x plus 6. So that's the equation in standard form. Same equation, just now in standard form. So y equals 3x squared minus 6x and plus 6. There we go. When it's in standard form, that's a positive number. Did it make a smiley face? It did. Is the number on the end of +6? That's my y-intercept. There's my y-intercept? It is. It matches. We were good. We did that one right. Okay? So now let's go do this one over here. We're just going to go from vertex form to standard form. So I'm just simplifying the right-hand side, following my PEMDAS rules. This y equals is still sitting out front. I just want to put this in standard form. So simplify it. In parentheses, can I do what's inside parentheses? Nope, they're not like terms. So do I do this exponent first or do I do the multiplication first? PEMDAS says after parentheses you do exponents, not multiplication. So we're going to do this little parentheses being squared. So that's x plus 2 times x plus 2. So I'm going to write that down here, just that little piece. X plus 2 times x plus 2. All right, so double distribution, x times x is x squared. X times 2 is plus 2x. 2 times x is another plus 2x. And 2 times 2 is a plus 4. So parentheses are now gone, and this is my 4 pieces. And then, of course, the 2 middle terms are like terms. So this now becomes x squared plus 4x. 2 somethings plus 2 somethings is 4 somethings. Don't change the somethings when you're adding and subtracting. And plus 4. We only add exponents when we're multiplying. X times x, you added the 2 little ones to get x squared. All right, so this thing is what was up here in this x plus 2 squared. So I still have a 3 sitting out front and a minus 5 on the end. So put your parentheses back around it. We got a 3 sitting out front. We got a minus 5 on the end. There we go. So now we just need to multiply with distribution, and then parentheses will be gone, and you can subtract 5 from it. So 3 times x is 3x squared. 3 times 4 is a positive 12x. 3 times 4 is a positive 12. And I still have a minus 5 sitting over here. So these two don't have any other like terms, but these two can go together. So this becomes 3x squared plus 12x. And 12 minus 7 is 12 minus 5 is a positive 7. So this whole thing, the whole right-hand side simplified down to this. It is now in standard format. X squared, x and a number. So this is y equals 3x squared plus 12x plus 7. The number in front is a positive number, so it's a smiley face. That matches. And the y-intercept is a positive 7. Yep, just like we did when looking at the picture, so we did that right. So standard form. I'll have another video going for the second page, so go watch it if you need. If you want to go ahead and just work a few problems and then check them and see how you did, do that.